Steve?
Yep, I can hear you.
Now I got it.
Okay. I started broadcasting too, just in case I had to let people know we were having a little technical difficulty. So we are
Let's
live.
see here. I want this and this.
So down at the bottom, share your screen.
Look, so you're not showing my screen now.
Nope, you have to do that.
Let me just go to where I was. No, not there.
Otherwise, you may have to send me your presentation and I can click through it.
I have share.
Okay.
It's desktop 1.
Yep, then go up in the upper left, should be share screen.
There we go.
There you go.
See it?
Yep. All right, so we are live while you're booting that up. Thanks everybody for jumping on. Sorry about the little technical glitch there. Jared from Dramm is here to talk to us about automated irrigation systems today, the different types, how they can increase plant quality, how you can decrease input costs, things like that. And like before, if you have questions, hover your mouse at the bottom of the screen, a little Q&A will pop up, just type it in. It comes to me, and I'll jump in and interrupt Jared, and we'll get the question answered. And also, if you're calling in and not logging in via computer, just please let your Testman rep know so you can get credit, the Hort Academy credit. I think that's it for housekeeping. So Jared, take it away, please.
All right. Thanks, Steve, for having me again, and everyone for joining on this. I'm sure where everybody is, it's fairly chilly, even though I'm just in Pittsburgh. It's not as chilly, but a good day to do a little bit of education. Yeah, today we're going to be talking about automated irrigation systems and the different types, the histories, how they work, what's associated with setting them up, keeping them running clean and such. So we're going to jump right in, talk a little bit about irrigation history, what actually is pressure compensation, the additional components that go along with the nozzles and drippers that you need, different types of installations, and questions on design, because that's probably the most important part of this entire discussion is how do you put all this stuff together and decide on what's the best fit for your greenhouse, nursery, retail, garden center. So I want to start off by saying this: the automated irrigation systems will never replace a grower's feel for how much water or fertilizer is necessary when growing a crop. Remember, you are still the expert. This is just an extension of what you do with a watering wand every day. This is just supposed to make life easier. You are just supposed to be in control of these systems so that you can be doing something else, but it should never be a complete replacement for what you know or have known for many years. So benefits of automated irrigation really begin with labor savings. That's kind of where it starts. They show up every day. They do the same thing every day if you tell it to do that. They don't call off. They don't water one way on a Tuesday and another way on a Saturday. So they're meant to work just the same way all day, every day, the way you set it up. The water savings compared to hand watering and some of the older irrigation, keeping the water where it needs to be. Fertilizer savings, again, keeping that fertilizer in the pot so you're not just sending money down through the pot, the basket, and just down the drain. So it could even be more efficient than hand watering. If you have an inexperienced waterer, and we all know at a greenhouse or a nursery, the most important job is someone who knows how to water correctly. These automated systems, again, because they're so efficient and even from pot to pot, can be better than an experienced hand water that might water too much or too little. So we want to take this all into account when we're trying to decide if this is the right system for us. And I want to start with John Dramm back in 1941. You know, someone, he figured out, let's stop putting our thumb over the end of a hose and put a water breaker on it. And this is still the most important way to do your watering. So it all starts with hand watering and having an understanding of how much we need to be putting on the crop based on the plant size, the crop, and such. From there, we went to different types of irrigation: pressure compensated and uncompensated. It started with uncompensated, which were just tubes with weights on the end, or inefficient nozzles that someone put on a riser or hung in a system. as opposed to the pressure compensated drippers we see today, both for baskets and pots on a bench, as well as the overhead systems with the check valve. So these are the two kinds of irrigation that are still out there, the older being the uncompensated. With uncompensated emitters, these are all based on the diameter of the tube and the pressure that you're working with. And it's not extremely even when it comes to water. And also it can be a little too fast, and everyone's probably seen it just flood right through a pot really quickly. So it's kind of wasteful with the water and the fertilizer compared to some of the newer systems that are out there. But back in the day when we needed something to get done quickly and we didn't only had so many people working, it was better than hand watering. So this was really our first run at labor savings in a greenhouse. And these are just a couple of examples of different types of an unpressure or non-pressure compensated. And you're going to hear me say PC. When I say PC, I'm using the term for pressure compensated. So these are versions of dribble tubes that are not pressure compensating, something like the Jane or the Jane one in the middle, the Chapin lead weight that is unavailable anymore, and of course the Dramm dribble tube on the top with the brown tubing. Those are all versions of the same thing, just a tube that sticks in a PE or polyethylene tubing or a PVC pipe. And you can see right here as an example of the differences, even based on pressure, that you get out of a dribble tube. They are not accurate from pot to pot. If you have different pressures, if you have a regulator, you can give it different amounts of water, but even down the line, it's going to fluctuate. So you're going to see different amounts of water coming out of the dribble tubes. And these are examples of what you see. On the left, you see a bunch of Chapin dribble tubes, and you can basically see a straight stream of water running out of these. The water's too fast. If the media is too dry, it's going right down through and not actually soaking the pot. You're having to come back and re-water over and over. And then on the bottom right on the bench, because they use so much water, you need so many supply lines to be able to feed these areas because they use just so much water. Let's compare this with the current, even though it's not very current, it's been out for 20 or 30 years now. This is a pressure compensating emitter. Basically, the water comes through the tube, it enters through there. It goes down through the diaphragm. The diaphragm, basically the line charges to a certain pressure, typically around 15 to 20 PSI. And when the line charges, all the emitters open up, the diaphragm opens up. There's a labyrinth that goes around the emitter that calculates the flow and makes sure it's all the same from dripper to dripper, from sprinkler to sprinkler. But this is what made water more even than it used to be with just sticking a tube in a line and turn it on as fast as it can go, was the invention of this PC or pressure compensating emitter. And what you're getting with this, since we're doing everything all at the same time with PC emitters, even watering across an entire zone. So you could have 10,000 baskets, and if you have enough water to water all those, they're all going to get the same amount. Because the emitter is working and calculating that flow rate, it's nice and slow. So you're able to actually saturate the soil properly, not having to come back and re-wet. You're using less water per dripper, which is allowing you to water a greater number of plants at the same time. You're using less water and fertilizer because you're not losing it out of the bottom of the pot. And those check valves keep those lines charged and keeping all the water from draining down to one pot, whichever pot might be the lowest on a line or on a table. It keeps that line charged so it's ready the next time you need to do a feed or an irrigation cycle. And just to give you an idea of what it looks like, this is a line of uncompensated dribble tubes. And when somebody turns on the water, this is what happens. It starts watering, so that first basket is getting water and the end of that line is getting nothing. So it's showing you how uneven the uncompensated dribble tubes of old were compared to a pressure compensated system where when I click a manual valve or a solenoid valve turns on, the line charges and boom, everything turns on at the same time. You get that nice slow irrigation cycle. And when I turn that valve off, the pressure drops in the line, the diaphragm closes, and the line stays charged, but you don't have all that water from the tube just feeding down to one basket and giving it and waterlogging it. So that's a good a showcase of the difference between uncompensated and pressure compensated emitters. And just to give you an idea of the difference, if I took 1,000 24-inch dribble tubes that had a flow rate of 6 ounces a minute based on that graph that we saw, and at 10 psi, I would use 46 gallons a minute, or would need 46 gallons a minute to feed those 1,000 baskets. If I took those same 1,000 baskets with a 24-inch pressure compensating emitter that we know puts out a half a gallon an hour and works over a variety of pressure ranges, we only need 8.3 gallons per minute to treat the entire place. The drip irrigation, again, just showcasing, if you can just hold for 1 second, I have to close the door, my wife's coming in here. I apologize, she's home from school because of the cold. So getting back to the talk, I apologize. Getting back to drip irrigation and pressure compensated versus uncompensated and the volume of water necessary, you might be limited on how much you can put in a specific area. You know, if you're using so much water with uncompensated, you can only water one line at a time. So you have to stand there or cycle through all of those different zones on a bench or a dripper, a basket dripper area. As opposed to a pressure compensated system that uses much less water, it allows you to do the entire greenhouse or number of zones at one time because you're using much less water. So we really have accelerated our ability to feed and water with these PC emitters. And again, I talk about the number of lines that you need on a bench just because they use so much water, as opposed to a PC drip. You see on the top left-hand side, we only need one line to feed 600 or 700 baskets. And opposed to just having one dripper per pot, we can actually have a single emitter split into 4 to divide up the water to save some money as far as the number of emitters we need on a bench. But we can do 4 ways, we can do 2 ways, we can do individual. There are a variety of ways to put drippers into plants on these types of benches. And of course, in the outdoor, we've got large PC pressure compensating dribble rings for large nursery containers. For B&B stock, if you were using just a single line before, there are now rings that are pressure compensated to properly saturate that root ball. Of course, modular drippers for mum crops and drip tape, which has become the go-to means of delivering pressure compensated irrigation to large areas of outdoor potted crops. So there's a lot more you can do with a PC emitter than you could with the old dribble tubes. With any of the new irrigation that we're working with, whether it's a dripper or a sprinkler system, there are other components that should be included when you're putting the design together. All irrigation should have some form of filtration, minimum of 150 mesh or 100 micron. And we like to have multiple levels of filtration or some redundancy. Even if you have a main filter on a 2-inch line, it's not a bad idea. It's actually a very good idea to still have a smaller 3/4-inch filter closer to the area, because there is a stuff called biofilm that even after your 4-inch line can accumulate and slough off and wreak havoc with your baskets. Of course, filter maintenance is key. You're going to want to be in charge or have somebody be in charge of coming through and cleaning up those filters every couple of weeks, or depending on your water source, maybe even sooner. Because if those become fouled in any way, they're really not doing anything to keep the emitters from getting clogged. So again, we're working with 40, 60 PSI is typical the pressure range we want to get. If you have a city water source or a pressure above 60 PSI, you're going to want to use a pressure regulator to keep that in the proper pressure zone for all these emitters or sprinklers that we're going to be talking about. And whenever we do talk about design and talking about what we're able to accomplish with sprinklers or emitters, we want to talk about flow than when we do about pressure. Everyone seems to say they have great pressure. We are much more interested in learning more about your flow capacity when it comes to deciding how much we can water at any given time. And when I talk about filter maintenance, these are examples of facilities that don't have proper filter maintenance. This is one of my favorite pictures on the right. This is my Chia solenoid valve. Obviously, someone has not cleaned that filter in a very long time, and things have just started to grow as they shouldn't be. So there's no use putting a filter if you're not going to have someone be in charge of maintaining that system. So obviously, along with filters and valves, we've got controls, and there are a variety of ways to do it. You can have hand controls like you have on the right with individual valves for your basket lines or sprinkler systems. There are battery operated controls for fields where you don't want to run wires. Some of them even have Bluetooth capabilities, individual controls within greenhouse, and larger centralized systems depending on the size of the greenhouse or nursery. And I have that listed here. Deciding on manual valves versus solenoids could be a choice. We recommend solenoid valves only because everybody remembers to turn on their manual valves, but they always forget to turn them off because they get pulled away, and then you just end up overwatering. Misting controllers versus standard irrigation controllers. The big difference between those is that a misting controller has the ability to run for a minimum on time of 1 second. The standard irrigation controllers only have the capacity to run for a minimum of 1 minute at a time. And so when you are working with young plants, we're typically misting on for 2 to 5 seconds. So we need that controller to have that capacity. Again, like I said, if you're working out in a field and you don't want to run wires to those individual solenoid valves, there are remote battery power valves, and some of them even have Bluetooth capability so that you can walk up to them with your phone on your app, change your cycle time. And then, of course, for larger greenhouses or nurseries, a central system that has a lot of options when it comes to valve control. So we've talked a little bit about drippers for baskets and for on the bench, but I want to get into some overhead systems. These are all money, labor-saving ways of getting your plants watered. It's just deciding the best way to do it based on the layout of your facility if you're a grower or a retailer. So lots of different types of overhead systems: hanging drop, bench riser, rolling bench systems, rigid rail for bench or floor, boom systems that are out there, and of course sub-irrigation. And when we break these all down, it might be deciding if we're doing a misting system for young plants, a general irrigation system for a finished crop. Is it a grower or is it a retail? These are all discussion points when putting a design together for someone for an irrigation system. When it comes to misting, we're working with finer particles than we are with a finished crop. The plants are younger, they don't need as much water, so it's more important to be able to deliver the right particle size. So nozzle choice is very important. Understanding the evenness of the pattern. We want to choose nozzles that have a little bit different trajectory so they don't have a lot of mid-air collision. We want as even as a pattern as we can on a mist bench for these young plants because they don't have the ability to last very long if they're not getting watered often enough. When it comes to nozzle choice, again, it's the evenness of the pattern and the coverage. We don't want spaces in between our sprinklers where our plants aren't getting wet. We want to design a system that is overlapping so we mitigate or eliminate or lessen the chance for portions of that bench or zone drying out or not being watered at all. A little bit of history about the earlier methods of overhead irrigation. They were mostly upright. We talked about the PC emitters having a check valve that would close and hold the water. The earlier systems didn't have a check valve, and if you ever inverted it, the plants would just get extra moisture in certain areas because the sprinklers would drip out. There also weren't a lot of choicers back in the day. You were basically mounting them on PVC risers, throwing them up in the air, and just getting as much of it as wet as you can. You didn't have a lot of choice on particle size, how far it would throw, and it was a lot of labor to install because of all the PVC. Again, it was pressure-based, so there was uneven coverage down a bay or on a bench back in the day. Current irrigation systems, there are a lot of choices. Nozzle selection is done on flow rate, coverage, whether or not we're using polyethylene tubing or we're going into PVC or metal, or we're working inside or outside, that might affect the droplet size that we must use for any wind that you might have in the area, or whether you're inside, you're not worried about that. The crop type and the stage of growth. This is all coming into play when we're trying to choose a nozzle for an automated system. Kind of running through the benefits of individual systems. The hanging drop system, probably the most popular and the most economical. It's a fixed system. You're basically hanging it from a pipe and using the appropriate length drop to get to where you need to get the proper coverage. That fixed drop length can be a little bit difficult to dial in exactly how far or how far or a pattern you're creating on a bench or on a floor. And they don't work great with rolling benches. If the bench moves left or right, you are no longer in the center of that bench, and half that bench isn't getting watered. Also long-term, the zip ties that are holding the tubing to the piping can break. Typically, it's right in the middle of the season when you can't get to it. So that should be taken into account when you're kind of deciding a system. Polyrail is a system that was developed by Dramm. It's basically a sleeve that you snap the tubing into. It can be used for benches or for floor. You do not need a hanging drop. We're basically directly sticking the nozzle into the piping, so we don't have to worry about a drop at all. It is very quick to install. It's a really clean look, so if you have a retail facility and a lot of drops, basically makes it very cluttered and hard to see across a bay, the Polyrail is a good choice because it stays above the plants and we don't have an impedance of the eye, so you can see across because there are no drops. They're a better choice for mist systems. A lot of times when the misting systems kick on for 2 or 3 seconds, the drops can kick left or right and can mess with the pattern on the bench. Because we're directly sticking, we don't have to worry about everything kicking left or right. There definitely is a higher initial investment with the Polyrail, but less long-term maintenance issues. A lot of customers that have rolling bench systems, either for finished crops or for young plants, we're using our Dramm ColorStorm Flex hose to attach our water line up to the bench. That allows the system to move left and right and keeps the irrigation nozzles directly centered over the bench to make sure that everything is getting properly irrigated. For larger areas, a boom system is an excellent choice. You can typically have multiple nozzles on a boom setup that can do a mist, can do a finished crop, or you can even set them up to do some drenching of individual pots if you have the proper control. There is a higher initial investment, and typically you do need more expensive controls to operate them. But for those doing a lot of monocropping or have large bays, booms can be a very good way of irrigating your crop. Sub-irrigation is definitely a different category than the overhead that we've talked about. This can either be capillary mat or flood bench or floor. There definitely is a greater initial investment. You can water a lot with your supply of water. You're recycling that water, but definitely design and setup or proper setup is key to make sure that we are irrigating properly, especially with some of the flood benches and flood floors where we want to make sure those tables are even so that those pots are being irrigated correctly. Also, there are a different set of rules when it comes to irrigating from the bottom, from the top, and also fertigation, so we don't worry about excessive salt levels building up in that pot. A lot of what we've talked about today is discussed whenever we are doing design for a customer. Again, versus 30 or 40 years ago when you just had a couple of choices, there are, as you've seen, a multitude of choices when putting systems together. There are also a lot more components than there were before. It's not just the nozzles and tubing anymore. It's filters, it's T's and elbows, it's solenoid valves, it's control boxes, filters and pressure regulators. So having an understanding of that is important. Questions, we always like to ask a lot of questions than just basically give answers. You should be asking a lot of questions as far as how you want to zone it, what your crop is, and what you're looking to get out of the system. So questions should also always be a part of the design process. There should never be just a cookie cutter method of irrigation design. There's just too many variables out there. And again, you want to work with the experts that are out there, the group at Tessman. Of course, Dramm's been doing irrigation for a long time, and there are other manufacturers out there that have the experience and should be asking all kinds of questions to help to give you the right design that you need. If you do have questions, you can get a hold of the group at Tessman, or if they're sharing this info with the customer base, this is the contact info. Myself and Kurt Becker do a lot of the design work for greenhouse and nursery customers. So if there is a question on design, you could certainly call us or email us as well. And I believe that's all I got.
We did have one quick question here, Jared, on that, the Bluetooth valve. Can you set up a program with that? Like if you come in and program it to have it go off, you know, the next day or the next night or something like that, that night? Or do you have to be within Bluetooth range? It's just more of an on-off thing.
Yeah, the Bluetooth, it is not a wireless system in that you can be sitting in your lazy boy in your room and then basically change the zone. You do need to be within 15 or 20 feet of the valve. It just makes it a heck of a lot easier to have it. The app is very easy to use, and you can basically walk up to it, make adjustments on the fly, but you do need to be nearby the solenoid valve.
And it isn't something you can program to have it go off, you know, at 10 o'clock at night or something like that.
You could if you were nearby at any time of the day and you wanted to change it, yes.
Okay, so you can set a program with it. You just have to be close by.
You can set a program just like any other controller. You can set it up as a misting controller to come on, you know, every 8 minutes for 12 seconds at a time. You can set up multiple irrigation cycles within it. It is just like any other standard irrigation controller. It's just right in the palm of your hand on the app.
Okay, yep. That's what I think they were asking.
Yep, and if you have a solenoid valve already and are looking to do this, you can purchase just the Bluetooth component and put it right on top of the valve that you have. So you can order it either way. Okay.
All right. I believe that was the only question that we had so far, but if anything comes up, I will certainly get in touch with you. With that, we'll end this webinar. Thanks, everybody. And I think there's another one coming up towards the middle of next week. Thanks, everyone. Have a great day.
Thanks.